So let's continue. I stepped here. So now we check the diagonal from right to left. So we check whether all its values are x's, and if it's so, we assign to winner x and the locations. Then we check our columns. So we have a for loop from 0 to 2. Then we have a let b assign, and we assign to it 0, and we have our for loop with j. So it checks whether ji is x, and it increases b by 1, and if it is 3, so all 3 values in the column are x's, it assigns to winner x and the locations. So so as you can see here, at first I remains constant, is here. I remains constant, but j is changing. So that's why we get our column. And every time as I increases, every time we assign to be 0. So this condition will work, to say so. And here we have the same for 0. We check whether the row is 0, and we assign to winner 0. Here we check whether the diagonal is the diagonal from left to right is 0. Here we check the diagonal from right to left, and here we check the columns. So I just copy pasted from the X part, and now here. So we have so in this way we check. So we have 2 for loops, and we check whether all places of all locations of our board are empty or not, and if they are not empty, we increase R by 1. So if all of them are not empty, our R will be 9. So now if win.winner is none and our R is less than 9, this is the condition when the game is there is no winner in the game, and it is not over. So our game continues. And in that case, our find winner function should return an undefined, and in other cases it should return the object win. So I think you understood this part. And now let's use this our functions, our next move function, our make move function, and our find winner functions. So first of all, we need an image 1, which is the image of our x, and then we need image 2, which is the image of our 0, and we have a draw function just for convenience. Well, first of all, we draw a black rectangle in our in our canvas. It will take canvas width and it will take canvas height. So then we draw green rectangles. So our large rectangle, our black rectangle, is to get these borders. You see they are black. This is because these green rectangles are drawn on this black rectangle. And to get these borders, the width of these borders is 2. So that's why at first I take the coordinates to 2, then and every time I leave a span of 2. And then I call this draw function, so it draws. Then we have this variable first. As I mentioned, our first can be either 0 or 1. So if it is 0, here, if it is 0, it means that so it is a randomly, or 0 or 1. So if it is 0, this means that it is the computer that the first step should be taken by a computer. So if it is 0, we assign to isX false, so it will be 0. Then we call our next move function, and it takes a random, as we saw, it will take a random number and it will assign to R these random coordinates. Then we check if our make move board R and isX is valid. This is a valid coordinates, and if it is valid, so if it doesn't return -1, it should make move. So it will take arguments board R and isX, and if it takes the argument R, so instead of the location we have the argument R, and argument 0 will be this number, and the location this one, location 1 will be R1. So it will assign to this random location 0. So the first step will be taken by the computer, and it will be 0. Then we need to draw this on our canvas, and that's why we do context.draw image 2, the image of our 0, and here we have these coordinates. So if we have R1 can be a random number from 0 to 2, and if it is, so it will correspond to one of these coordinates. So this strange number is because of these borders. If you calculate this, you will get that. So if R1 is 0, it will get 0 times 202, it will be 0, and plus 2 will be 2. And if this is also 0, we will get 2 also, and we will get these coordinates of this rectangle, and it will draw here 0. So, and here we have this function image2.onload, because sometimes there are difficulties for the computer to onload that picture, and it just doesn't draw it. So in order to evade that, to avoid that problem, I use this onload function. So it will always draw that, it will always work, it will just work. And now we have our add event listener, which will be our clicking. So if we click, it will change something in board, and it will draw X on this canvas. So we have add event listener, and it will take as an argument click, and our function, and this function will so when we click, it will do this all code, and I'll explain this code in the next video.